In section 8.3, we look at products and quotients in trigonometric form. So we're talking about multiplying or dividing complex numbers in trigonometric form. So we start with a theorem. Suppose z1, our first complex number, has a modulus r1 and an argument theta 1, and z2, our second complex number, has a modulus r2 and an argument theta 2. If these are two complex numbers in trigonometric form, then their product, z1 times z2, is given by multiplying the moduli and adding the arguments. So first, let's go ahead and prove this theorem. So we start with the complex number z1, which is here, multiplied by z2, which is here. The first thing we can do is rearrange what we have here. So we have r1 times r2 times the cosine of theta 1 plus I times the sine of theta 1 times the cosine of theta 2 plus I times the sine of theta 2. So you can see we already have r1 times r2, which is a part of the result. Now what I'm going to do is just use multiplication of polynomials basically here to multiply this out. And when we multiply this carefully, we get this. So just verify, multiply here, multiply here, multiply here, and finally multiplying here. Now let's go ahead and simplify a little bit further. So one thing we can notice is that I squared is equal to -1. So that last part there can be rewritten as negative sine of theta 1 sine of theta 2. And then the beginning is the same. And then in the middle here, we can factor out an I out of both of those. So if I pull out an I there, we get sine of theta 2 cosine of theta 1 plus sine of theta 1 cosine of theta 2. Now we should just notice that if you take cosine of theta 1, cosine of theta 2 minus sine of theta 1, sine of theta 2, those can be combined using the sum or difference formula for cosine. And it turns out that that is the cosine of theta 1 plus theta 2. And then in here, we have plus I multiplied by, look at what you have. You have sine of theta 1 cosine theta 2 plus sine of theta 2 cosine of theta 1. And that is the sum formula for sine. And then all of that, of course, is multiplied by r1, r2. And so that pretty much proves the result. So to multiply two complex numbers when they're in trigonometric form, we multiply the moduli and we add the arguments. Let's take a look at some examples. So in our first example, we are going to multiply the complex number 3 cosine 40 degrees plus I sine 40 degrees and 5 cosine 10 degrees plus I sine of 10 degrees. So to multiply those, we are simply going to multiply the moduli. So we take 3 times 5. And then we know our complex number is going to be in trigonometric form. So the only question is, what is the angle here and what is the angle here? Well, we know that when we multiply two complex numbers, we take the angle of the first complex number and we add it to the angle of the second complex number. So this should be 40 degrees plus 10 degrees. And that goes in both spots here. And then if we just complete this, 3 times 5 is 15. We have cosine of 50 degrees plus I times the sine of 50 degrees. In our next example, they ask us to find the product of z1 and z2 in standard form. And then they want us to write z1 and z2 in trigonometric form and find their product again. So first of all, to multiply z1 times z2, in standard form, we are simply going to take 1 plus I radical 3 and multiply that by negative radical 3 plus I. And we'll do this multiplication carefully. So 1 times negative radical 3 is negative radical 3. Then we have 1 times positive I, which is positive I. Next we have I radical 3 times negative I radical 3. So positive times negative is negative. Radical 3 times radical 3 is 3. And then we also have an I there. And finally we have I radical 3 times I. So positive I times positive I is positive I squared. And then there's a radical 3 in there as well. So now to finish this, we will just simply rewrite this as negative radical 3. And then here we have positive 1i, take away 3i, that's negative 2i. And I squared here, remember that's equal to negative 1. And so that just ends up being negative radical 3. Combining negative radical 3 and negative radical 3, we get negative 2 radical 3 minus 2i. So here is the product of those two numbers in standard form. Next, they want us to write these numbers in trigonometric form and then find the product once again. So to do this, it's helpful to have a little graph here. So z1 is the number 1 plus I radical 3. If I draw a picture of this complex number, it will look something like this. The real part is 1, the imaginary part is radical 3. We know this is a 60-degree angle, and the hypotenuse here is 2. So z1 can be written as 2 times cosine of 60 plus I times sine of 60. And for the second complex number, we have negative radical 3 plus I. That will occur in the second quadrant. Negative radical 3 plus I looks something like this. The reference angle here is 30 degrees, which means the argument of the complex number is 150. And it also has a modulus of 2 units. So the second complex number is equal to 2 times the cosine of 150 degrees plus I sine of 150 degrees. So now we've put both of those numbers into trigonometric form. We're going to use those trigonometric forms to multiply these numbers together. So z1 times z2 is going to be the product of the moduli, so 2 times 2. And then for the angle, we're going to take the angle of the first complex number and add it to the angle of the second complex number. And same thing here. So this is equal to 4 times the cosine of 210 degrees plus I times the sine of 210 degrees. So this is our answer in trigonometric form. But what I could do here is I could get the actual values of cosine of 210 and sine of 210. And if I do that, the cosine of 210 is actually negative radical 3 over 2. And the sine of 210 is negative 1/2. So we have negative 1/2 times I. And notice that if you distribute the 4 here, 4 cancels with 2 and gives us 2. 2 times negative radical 3 is negative 2 radical 3. And the same thing happens here. 4 cancels with the 2, leaving us with negative 2i. And of course, the point is the answer that we got here using the trigonometric form is the same as the answer that we got up above here when we just did it all in standard form. So hopefully this problem makes you a believer that multiplying complex numbers in trigonometric form actually works. Next, we talk about de Moivre's theorem. De Moivre's theorem involves taking a complex number and raising it to an integer power. So if I have a complex number in trigonometric form, that number raised to the n power turns out to be the modulus raised to the n power and the argument multiplied by n. And down here we give a simple example of that. So if we are squaring a complex number here, all we have to do is square the modulus and then multiply the argument by the power here, which is 2. So let's take a look at a couple of examples. So in the first example, we are asked to find 1 plus I to the 10th power. Now, to appreciate de Moivre's theorem, just imagine if you didn't have it. To do 1 plus I to the 10th power, you would have to multiply 1 plus I by itself 10 times. All right, so there would be 10 factors here. And that would be a lot of work. But because we have de Moivre's theorem, all we have to do is take the complex number 1 plus I, put it into trigonometric form, and then we can apply de Moivre's theorem. So let's go ahead and put 1 plus I in trigonometric form. So the number 1 plus I, if you graph it, it is a complex number in the first quadrant. The real part is 1, the imaginary part is 1. The hypotenuse here would have to be square root of 2, and the angle is 45 degrees. So the complex number 1 plus I in trigonometric form is radical 2 times the cosine of 45 degrees plus I times the sine of 45 degrees. So now we are taking this number and raising it to the 10th power. De Moivre's theorem says to take this number and raise it to the 10th power, all we have to do is take the modulus here, radical 2, raise it to the 10th power, and then take the argument here, which is 45 degrees, and multiply it by 10. So this is going to be the cosine of 10 times 45 degrees plus I sine of 10 times 45 degrees. And now we just need to do the math here. So let's start with radical 2 to the 10th power. Yes, you can use a calculator for this, but we can do it a different way. We can rewrite this as radical 2 to the 2nd power and then raise that to the 5th power. And we could do this because 2 times 5 is 10, right? So if I write it like this, notice that radical 2 to the 2nd power is just 2. And so this just becomes 2 to the 5th power, and 2 to the 5th power is 32. So we end up with 32, and then on the inside we have the cosine of 10 times 45 degrees, which is 450 degrees, and then of course plus I times the sine of the same angle. And now I just want to write this in standard form. So 450 degrees, if you subtract 360 degrees from that, you'll see that it is actually coterminal with 90 degrees. So what I have here is 32 cosine of 90 degrees plus I times the sine of 90 degrees. And this is really simple because we know the cosine of 90 degrees is 0 and the sine of 90 degrees is 1. So what we have here is 32 times I. Next, let's talk about division. So if I have two complex numbers in trigonometric form, the question is, how would we divide those complex numbers? Well, remember what we did when we multiply. You can look at that again if you want. We do just the opposite when we divide. So if I want to divide the complex number z1 by z2, I'm going to divide the moduli. So I take the modulus of the first number divided by the modulus of the second number. And then for the arguments, we subtract them. We take the first argument minus the second argument. So when we did multiplication, remember, we multiplied the moduli and we added the arguments. So here we're just doing the exact opposite of both of those. So as an example, let's divide the number 20 times the cosine of 75 degrees plus I sine of 75 degrees by 4 times cosine of 40 degrees plus I sine of 40 degrees. So let's go ahead and write this down as a division problem. And now all we have to do to complete this is divide these two numbers. So that will be 20 divided by 4. And then for the angle, we're going to have 75 degrees minus 40 degrees for both angles. Right? The angles inside of the cosine and the sine are always the same when you're talking about complex numbers. So what we have then is 20 divided by 4, which is 5, and then cosine of 35 degrees plus I sine of 35 degrees. And this is the answer in trigonometric form. So once again, it's very simple to multiply or divide complex numbers when they are in trigonometric form. And it's also easy to raise them to powers when they are in trigonometric form. Let's take a look at one last example. So here we're being asked to divide z1 by z2 and leave the answer in standard form, and then change each to trig form and divide again. So first of all, we want to do z1 divided by z2 sort of the old-fashioned way. We're going to take the number 1 plus I radical 3 and divide it by the number radical 3 plus I. So to do this, you need to remember that when you divide complex numbers, you actually don't divide. You're going to multiply the top and bottom by the conjugate of the denominator. So that would be radical 3 minus I. We have to do that to both the top and the bottom. Now, in the denominator, there is a shortcut for multiplying complex conjugates. You take the real part here, which is radical 3, square it, plus, and then you take the imaginary part. Now, the imaginary part here is positive 1, and we square that. And that number is 4, right? That's just 3 plus 1. And then on top, you have to multiply. So we have to do the FOIL process on top. And when we do that, 1 times radical 3 is radical 3. 1 times negative I is negative I. I radical 3 times radical 3 is 3I, right? So positive 3I. And then finally, we have I radical 3 times negative I, which is negative I squared radical 3. And then we just have to finish this up, right? Simplify. So negative I plus 3I, that's positive 2I. So we have radical 3 plus 2I. And then right here we have negative I squared, which is negative 1, which of course is positive 1. So positive 1 times radical 3 is radical 3. And finally, what we have here is 2 radical 3 plus 2I divided by 4. And one last thing we can do is divide each of those by 4. And our final answer here would be radical 3 over 2 plus, and then the second one there is I over 2, or you could say 1/2 I. All right, so that's what we get when we divide the numbers sort of the old-fashioned way. Now for the second part of this, they want us to change them to trigonometric form and divide again. And then once we do that, we'll verify that we get the same answer. So our first complex number, z1, is 1 plus I radical 3. I can draw a graph of this complex number. Real part is 1, imaginary part is radical 3. Modulus will be 2, argument is 60 degrees. So z1 is 2 times the cosine of 60 degrees plus I sine of 60 degrees. And the second complex number, radical 3 plus I, is also in the first quadrant and has a real part of radical 3, an imaginary part of 1. So the argument is 30 degrees, modulus is 2. And so z2 is 2 times cosine of 30 degrees plus I sine of 30 degrees. And so now when I want to do z1 divided by z2, I'm simply taking the first complex number here and dividing it by the second complex number here. Now, to do the math there, all we have to do is divide these two numbers. So 2 divided by 2 is 1. And then for the angles, we have to subtract the angles. So we need to take 60 degrees minus 30 degrees, which of course is 30 degrees. And we have the same thing for the second angle. So this is our answer in trigonometric form. Now let's go ahead and write this answer in standard form. So I would like to point out that in front of this, we have the number 1, right? Because 2 divided by 2 is 1. So when I go to graph this, what I have here is a complex number with a modulus equal to 1 and an argument of 30 degrees. And you have to remember that the short leg of a 30, 60, 90 triangle is half of the hypotenuse, and the long leg is radical 3 times the short leg. So this complex number in standard form is radical 3 over 2 plus 1/2 I. And then, of course, I would just point out that these two answers are the same. So to multiply or divide complex numbers, you can do them in standard form or trigonometric form, and you get the same answer either way.